In today's video, we are going to look at solving one variable inequalities. And so that is your learning target for today, is to solve and graph a one variable inequality. So let's think about the difference between an equation and an inequality. So when x is equal to 3, how many solutions does x have? And there is only one solution, and that's 3. But if you have x is greater than 3, how many solutions are there? And there are an infinite amount, and it starts with 4 and then goes to infinity. And so there are an infinite amount of solutions with an inequality versus one solution with an equation. And so as a review, let's go ahead and solve this equation. I want to isolate x and get it by itself. So it looks like I should add 5 first to both sides. And I'm left with 2x is equal to 3 plus 5 is 8. Divide both sides by 2. And I get that x is equal to 4. So that's my one solution when I have an equation, x is equal to 4. And I can check this by plugging in 4 for x and solving, and I would get that 3 is equal to 3. So I know that I did not make any mistakes. But what if we are given an inequality? And so let's look at 2x minus 5 is greater than or equal to 3. So how many solutions are there going to be? Well, with an inequality, we know that there are going to be infinitely many. Infinitely many. What is the smallest solution for x? Okay, and we're going to actually solve for this on the next slide, but whatever we get, that is going to be called the boundary point. It's the smallest solution before crossing over to not true. So if I say x is greater than or equal to 2, 2 would be my boundary point, because if I cross it and I go less than, such as 1.99, I would be crossing the boundary of 2. And so what is the significance of the boundary point? And basically what I just said, right? It's the smallest solution for that equation. And so now we are going to write an inequality that represents the solutions for x. And then on a number line, we're going to graph it. So let's go ahead and solve this inequality. Now, here is a very important rule that you cannot forget, and please, if you need to write this down, go ahead and do it. But when you divide or multiply by a negative, you must flip the sign. And I don't think we're going to see an example of that on this problem, but we will in the next problem. So to solve an inequality, one method is solve it as you see it. And so I want to get x by itself just as if it was an equation. So I'm going to add 5, and I have 2x is greater than or equal to 8. I'm then going to divide both sides by 2, and I get x is greater than or equal to 4. There's my solution. And to graph this, I'm just going to, maybe I'll put 4 is here, 5, 6, 7, 8, 3, and 2. If x is greater than or equal to 4, I'm going to have a circle here, and x is greater than, which means all of these solutions here. Now, another important information that we need to take care of is the fact that it's greater than or equal to. Sorry, go down here. Greater than or equal to, which means this needs to be a closed circle. So as a reminder, if you have something that is greater than or less than, you're going to have an open circle. But if you have a less than or equal to or greater than or equal to, your circle, your point is going to be shaded in. Okay, so this is my solution to this inequality algebraically, and this is my solution represented graphically. That is how you solve an inequality. Example number 2. Let's go ahead and begin as we did. So we want to get y by itself. I'm going to subtract 4 from both sides. And I've got negative 2y is less than 6. This is where that really important fact that you must remember comes in. And when you divide or multiply by a negative, that means you must flip the sign. And so because here I am dividing by negative 2, I must flip the inequality sign. And there's my solution represented algebraically. And now I must represent it graphically. So if y is greater than negative 3, let's put negative 3 here, negative 2, negative 1, 0, negative 3, negative 5, and y is greater than negative 3. So all these values over here represent my solution set inequality, and it represents it graphically. Okay, so that is very important. Many students usually or sometimes forget about that very important rule. Let's try another example. You're going to start solving it as you would any equation. I'm going to, looks like subtract 3. Oh no, let's see, I've got a y here actually, so I'm not going to subtract 3. I'm going to add 2y to both sides because since those are my like terms, I get 3 is greater than negative 5 plus 2 is negative 3y. I need to get y by itself, so I'm going to divide both sides by negative 3. And again, I know when I divide by a negative number, I need to flip my sign. And so I am going to have 3 divided by negative 3 is negative 1. My sign is going to flip, and this reduces to 1y. And so I have got y is greater than negative 1. So again, I don't have an equal to as part of my inequality, so I'm going to have an open circle. It looks like y is greater than negative 1. 1, 2, 3, 4. It's very important to label my number line, and it gets shaded to, yep, this way. Okay, so that is how you solve an inequality. Now, there is a different way that you can solve an inequality, and maybe the second way is how you're taught, and that is changing the inequality to an equation, solving it, and plotting that point. And then you must test both sides of the inequality. If it becomes true, then you know that the inequality sign is correct, and it would be, it looks like greater than. But if you test it and you get a false statement, that means that that number was not a solution, and so you would not shade it that way. And so just in case this is how you were taught and you are comfortable with this, I'm leaving this up here, and you can go ahead and pause the video and review this. Or personally, I find it easier to do it the way that I just taught you guys. And just remembering that when you multiply or divide by a negative, then you flip the sign. Thank you so much.